What we want to do now, we want to prove Heron's formula. Um, so what we have arbitrary triangle. I draw arbitrary triangle. And let's label this triangle ABC. And what is given to me, three sides. Call this a small a, small c, and small b. So what is the given is A, B, and C. And what I want to find, area of the triangle. So how to do this? Uh, I claim that you know how to do this if you know law of cosine and even you don't know this Heron's formula. Because idea is like this. So uh, if you know angle alpha, what is BAC, which you don't, then you would be able to find this area of the triangle, because area of the triangle would be 1/2 C times B times sine angle alpha. So you don't know sine angle alpha, but you know A, and using A, B, and C, three lengths of the three sides of the triangle, what you can do, you can solve for the cosine of the alpha. And for the cosine of the alpha, when you solve, you can solve for the sine alpha. And in this case, sine alpha always will be positive. So this is how you would do uh, solving this problem if you know law of cosine, but you don't know Heron's formula. So Heron's formula is really solving for area of this triangle using law of cosine in general form without numbers. So, and what I just said, I will implement this. So now, I wrote this area of the triangle is 1/2 BC sine alpha. And I know that I will be able to use law of cosine to find cosine alpha. But it's pretty inconvenient to convert from the cosine alpha to the sine alpha. It's much easier to convert from the cosine square alpha to the sine square alpha. So what I will do this trick. I will say, so area of this triangle equal square root of the area of the triangle square. So this gives me square root of 1/4 c square b square sine square alpha. So I introduce square root, but in return, what I got that now I have sine square alpha, not sine alpha, and then it's easy for me to convert to the cosine alpha. So I will use main identity that sine square alpha plus cosine square alpha equal 1. Therefore, I can write 1/4 c square b square. Sine square alpha I write as a 1 minus cosine square alpha equal, so square root, I will write 1/4 c square b square, and 1 minus cosine square alpha, this is the 1 square minus cosine square alpha, so I can write this as the difference of the squares. Give me 1 minus cosine alpha times, go to next line, just continue, give me 1 plus cosine alpha, and it is times here. So this is what I have so far. Next, what should I do? I have to use law of cosine and solve for the cosine alpha. So using law of cosines, I can say a square equal c square plus b square minus 2bc cosine alpha. From here, if I solve for the cosine alpha, so this gives me c square plus b square minus a square divide to the 2bc. Technically, I already done, so because I can plug expression for the cosine alpha, and I will get final formula which depend only on the a, b, and c, but this formula was pretty big and ugly, so I want to write something in more presentable way if possible. So what I do now, after I solve for this, on the side I just write expression 1 minus cosine alpha. So what it will be? It will be 1 minus c square plus b square minus a square over 2bc equal, so give me 2bc minus c square minus b square plus a square, and all this divide to the 2bc. So now, what I can do in the numerator? In the numerator, I can write as a square minus, so I will group first 3 terms and factor minus outside. So this gives me c square plus b square minus 2bc, and everything divided by 2bc. So now in the numerator I have a square minus, in the parentheses I have different square of the difference. So will be c minus b square over 2bc equal. So now in the numerator I write this as a difference of the squares. This gives me a minus c plus b times a plus c minus b divide to the 2bc equal. So I want to simplify more. So let's write this my division line, and I will use some trick in the numerator. I want to get expression a plus b plus c, and later you will see why I want this. So I can write a plus b plus c, but I have a, I have b, but I have minus c, not plus c. So if I said a plus b plus c, I have to say minus 2c. And in the second expression, in the parentheses, I also want to get a plus b plus c. A plus b plus c. Okay, so now, but I have minus b, not plus b, so it will be minus 2b divide to the 2bc. So what I will do now, I will introduce new variable. So I will write this here. Say like let S equal A plus B plus C divided by 2, right? So S is my semi-perimeter. So it's 1/2 of the perimeter of the triangle. Then what I can write here, I have 2S minus 2C times 2S minus 2B. And everything divided by 2BC. So the last step here, I can factor 2 out of the parentheses twice. Give me 2S minus C times 2S minus B over 2BC. So 1, 2 will be cancelled. And I will have S minus C, another 2 here, 2S minus B divide to the BC. So I will just circle this. Now I do the same thing for the expression 1 plus cosine alpha. So this gives 1 plus C square plus B square minus A square divided to the 2BC equal 2BC plus C square plus B square minus A square over 2BC. So here, if I group first three terms, I get complete square C plus B square minus A square divided to the 2BC equal C plus B minus A, right, there's 2BC on the bottom, times, I continue on the next line, so times C plus B plus A equal. So now what I do the same trick as before. This is C plus B plus A, but then I have to subtract 2A. And in the next expression in parentheses, I already have A plus B plus C. I don't need to do anything. I write A plus B plus C and divide to the 2BC. So now I express A plus B plus C through the semi-perimeter S. Give me 2S minus 2A times 2S over 2BC. So 1, 2 is cancelled in numerator, denominator, and I can factor another 2 in the numerator, S minus A divide to the BC. Now what I have, what was my area equal? Square root, let's see what we had before. We had 1/4 C square B square, 1/4 C square B square times 1 minus cosine alpha times 1 plus cosine alpha. Right? So what I do, I will substitute expression for 1 minus cosine alpha and 1 plus cosine alpha. So I will have this pretty long square root, I expect. So give me 1/4 c square b square. Okay, 1 minus cosine. This is, I believe, this one. Okay, and 1 plus cosine is this one. So go back to the black color. So 1 minus cosine alpha, it's 2s minus c s minus b divide to the bc times, oops, here missed one s. So 2s s minus a divide to the bc. So what we get that in the numerator we have c square b square, and in the denominator we have bc times bc. It's the same b square c square. So b square c square I cancel, and also in the numerator I have 2 times 2, 4, and multiply by 1/4 give me 1. I get my final formula. That I have s minus a, s minus b, s minus c. And this is indeed Heron's formula, where my s, like this, where s equals semi-perimeter a plus b plus c over 2. This is the final result. Thank you.